Hi guys! Today's lesson is the beginning of our geometry unit. So we're getting ready to start a new unit. Let's get going. The first lesson that we're going to do is finding the area and perimeter of rectangles and also of parallelograms. Now hopefully this is review for you guys, so this first lesson or two should kind of feel like it's a little easier, but we're definitely going to ease into harder stuff pretty quickly. So let's go ahead and get started. Today's objective is that you will hopefully either remember or learn to find the perimeter and the area of rectangles and parallelograms. So area and perimeter of rectangles, rectangle being a shape that has four right angles and sides that are the same here and the same here. And then a parallelogram having equal sides here and here, and then congruent angles here and here. So the first one that we're going to do, the first part is the perimeter. So the perimeter is the distance around the outside of the object, of the figure. So like if you were to put a fence around it, another way a lot of people like to remember it is because it has this word rim, like a basketball rim. So the rim is the part outside the basketball hoop part, so it's the rim, the outside part. And the way that we find that when we're doing our problems is to add up all the lengths of the sides. So add up being plus them all together. So for our first example, we're just going to find the perimeter of the rectangle. You can see that we've got our right corner right here, and that's going to indicate that the rest of these corners are right because they're telling us it's a rectangle. So we have one side that is 4 centimeters and another side that is 6 centimeters. So in order to find the perimeter, we need to go around the outside. The first problem that I see, though, is that we need to figure out what our missing values are up here and up here, as well as over here and this one. So obviously pretty simple. If this side is 4 centimeters, this one is going to be also 4 centimeters. And then if our bottom width is 6 centimeters, our top is also going to be 6 centimeters. So now that we know the length of all the sides, we can just add them up because we're going to add up the lengths of all the sides. So starting with this side right here, we've got 4 centimeters, so we're going to take 4. And remember, we're going to add. The next side is 6 centimeters, so you add to that 6 centimeters. And then we're adding another 4, which we found on our own. And finally, our last side of 6 centimeters. So a little simplification, I know that 4 plus 6 is 10, and 4 plus 6 over here is 10, so if I do 10 plus 10, I'm going to find that the perimeter of this is 20 centimeters. Okay, on to example 2. So for example 2, we're going to again find the perimeter, but this time it's of a parallelogram. So we need to kind of notice that these angles are not perfect right angles, but we can still figure out the perimeter by adding up all the sides. So we've got one side that is 5 feet, and we know that the corresponding side for that is over here, so this one is also going to be 5 feet. And then we've got a base of 7 feet. So this is our corresponding 7-foot side. So now all we have to do is add up all the sides. So I've got 5 feet for this side. I'm going to add to that this side, which is 7, plus another 5. And finally, plus another 7. So to solve this, you can put some of these together. Everybody can do it different. I mean, it's no right or wrong way. I know, though, that 5 plus 5 is 10, and that 7 and 7 is 14. So the perimeter around the outside of that parallelogram is going to be 24, and then we want to make sure we add our unit, and everything was in feet, so it's 24 feet for the perimeter of this one. Okay, now we're going to try some different types of problems. Next, we're going to be figuring out area of these two shapes. So the area is going to be the number of square units that are inside a figure. So there's a couple different ways of thinking about this. The first being in words. The way that we find area is represented by the letter A, and this is for a rectangle, or for a parallelogram is going to be to take the base length, which is going to be represented by the letter B, times the height, which is going to be represented by the letter H. And if you had a formula for this, it would look like this: A equals lowercase b times h, so area equals base times height. So first we're going to talk about for a rectangle. So a rectangle, when you go to find your base and your height, you want to look for your base on the bottom, and your height is going to be at a 90-degree angle right next to it. And for a for a rectangle, it's pretty basic. And if we had an example like where we had a base of 5 and a height of 3, you would just take your base, which is 5, times 3, which is your height, and get 15. So there's 15 units, or 15 squares, that would fit inside that rectangle. Now for a parallelogram, it's a little different, a little bit harder to understand. So I want you to think of a parallelogram. If we were to take the parallelogram and kind of take scissors and slice it open right here, I want you to note that you can, and you could do this with paper if you really wanted to, you can take this side and move it over here, and watch what happens. When you move it over here and then, push it back together, you can see that this actually creates a rectangle, just like what we're dealing with. This is why rectangles and parallelograms have that same formula. I know it's kind of something that a lot of us just memorize and don't really understand why, but this is a good visual example of why that makes sense. So now that we've seen that, hopefully this will make a little bit more sense. So the base is still going to be like your bottom, but your height is that spot where we sliced it, and it needs to be at a 90-degree angle, and it needs to be at a spot where you're going to connect the top and bottom pieces. Like you wouldn't want to connect, right here where you're touching one of the angled sides, but you want to end and begin at 90-degree angles here. So make sure that you're using that. You don't want to use anywhere on the slant, so we want to avoid these slants, because these slants are going to give us incorrect answers because they're not quite as long. Or actually, they're longer. I lied. They're longer. So we want to make sure we always find our height, kind of like where we would do that cutting part. So if we were going to do an example, remember that our base is pretty easy because it's just going to be down here at the bottom, and you want to only use the part that is our actual figure. So this part right here, which ends up being 1, 2, 3, 4, 5. That's where they get this 5. But then for your height, that's the tricky part. You want to use an angle that's going to be at a 90-degree angle and touch both bases. So one of these, it could be that one, it could be this one, or this one, or this one. Any of those would work as your slice point. But you want to take that measurement, which is going to be a height of 3. So it's still a height of 3, which is how they end up getting 5 times 3 equaling 15 units, which is the same as the rectangle next to it. It has the same area, although it doesn't look like it's the same. So we're going to do some examples to find area. And for these, though, we're going to have coordinates that were given. And we're going to take our coordinates, and we're going to graph these on a coordinate plane. and go from there to find our area. Alright, so our first coordinate is at -3, -2. So remember that we walk before we ride. We're going to walk to -3, and then we're going to ride the elevator to -2 floors. Oops. Maybe not. Okay, our next point's at +3, -2. So we're going to walk to +3 and then ride the elevator to -2. Next we have +3, +1. So walk to the positive, or to 3, yeah, and then you're going to ride the elevator to +1. And finally we've got -3, +1. So go back to -3, ride the elevator up to 1. So now you're going to connect that to find our rectangle. So now that we have our rectangle, we need to find our base and our height, because remember our formula is that our area is going to be our base times our height. So for our base, we've got the length down here at the bottom. So this is a length of 1, 2, 3, 4, 5, 6. And then our height's going to be over here. We have a height of 1, 2, 3. Just simply count the squares. So now to find our area, we would just plug these numbers in. So if area is equal to base times height, we've got a base of 6, so I'm going to substitute 6 for my base, and then my height is 3, so I'm going to substitute 3. So our area ends up equaling 6 times 3, which is equal to 18, and we don't have a unit, so we're just going to call it units. And because it's area and they're squares, we call it units squared, square units. Okay, let's do one more example like this where we've got our vertices, and so we'll go ahead and graph those to start with. So our first coordinate's at -4, -4. So we're going to walk to -4 and then ride down to -4 and put our first coordinate. And then our next one's at +1, -4. So I'm going to walk 1, ride down 4. Then I've got 3, 0. So I walk to 3 and I don't ride anywhere. I'm just going to stop right there in the lobby and not go up or down. And then I'm going to go to -2 and do the same thing, -2, 0. So I'm going to go back to -2 and nowhere up or down. And then I just need to make my lines to connect my shape. And you can definitely see that this one is a parallelogram and not a rectangle. So to find our area, we're still going to use that same formula, area equaling base times height. However, remembering that our base is the bottom of our shape, and our height is how tall it is anywhere from the base to the base, creating that 90-degree angle. So now we can take our measurements from here. So our base, count the squares, 1, 2, 3, 4, 5. So we have a base down here of 5. And then our height is 1, 2, 3, 4. So now we just need to substitute. We're going to take 5 and substitute that for the base. So your area equals, instead of b, we're going to put 5. And then our height is 4, so 5 times 4. Simplification, you've got 5 times 4, which is 20. And again, you're going to put it in just units because we don't know if it's in feet or whatever, but because it's area and it's squares, we're going to call it units squared.